Hello all, let's talk about the construction and working of ruby laser in this video. Ruby laser is the first ever solid state laser which has been successfully used. In the year 1960, T.H. Meinman gave the first demonstration of laser activity using ruby crystal. The photograph of T.H. Meinman and the laser that he has designed and developed was shown here. Now let's see construction of ruby laser. Ruby is a crystal. It is aluminum oxide Al2O3 in which some of the aluminum ions are replaced by chromium ions. This is done by doping small amounts of chromium oxide in the melt of purified Al2O3. For the purpose of construction, the cylinder of ruby crystal is selected. The length of this ruby rod will be in the range of 2 cm to 30 cm and the diameter will be smaller as compared to length, and diameter will be in the range of 0.5 cm to 2 cm. This ruby rod is polished at two ends in such a manner that one end will become fully reflecting surface, other end will be partially reflecting surface. Helical xenon flash lamp is wound over the ruby rod and the power supply is connected to xenon flash tube. As high temperature is produced during the operation of laser, the rod is surrounded by liquid nitrogen to cool the apparatus. Here you can see the cooling system is provided. From the partially reflecting surface, one can observe the laser output. How laser output is achieved, that we are going to see. This is all about the construction of ruby laser. Let's see some of the parameters about the ruby laser. Here we have seen ruby is made up of aluminum, oxygen and chromium. Out of that, chromium ions will act as active centers, means they are going to take actual part in the stimulated emission process. So chromium ions in ruby laser, ruby crystal are nothing but the active centers, whereas the complete ruby rod will act as an active medium. A helical flash lamp filled with xenon is used as the pumping source. Here in solid state laser, optical pumping is selected. We have seen the ruby crystal is polished, grounded and made flat at the ends. The one of the end is completely silvered while the other is partially silvered to get the output. The two polished ends act as an optical resonator system for the ruby laser. We'll see how laser light is produced in case of ruby laser. Ruby is having three levels energy system. There will be E1 ground state, E2 metastable state and E3 which is excited state. The high amount of energy is released when a capacitor is coupled to a xenon flashlight that contains a ruby crystal. Some of the energy is absorbed by chromium ions in the ground state. Thus, the optical pumping raises the chromium ions to the energy levels in the band E3. Chromium ions, by absorbing this much amount of energy, will get excited to the or will get transit to the excited state E3. This mechanism is known as absorption. The transition of chromium ions from ground state to E3 state is due to the absorption of radiation. When excited, chromium ions come into touch with the crystal lattice, they lose some of their energy and decay to the metastable state E2, resulting in population inversion. Because we know the time period of metastable state is quite higher, so more collection of chromium ions will be seen at the metastable state. While having transition from excited state to metastable state, there will not be release of radiation. So this transition is also termed as non-radiative transition. As E2 is metastable state, chromium ions will stay there for a longer amount of time. As a result, pumping causes amount of chromium ions in the even ground state to continue decreasing while the number in E2 state continues to increase. As a result, the excited state contains more chromium ions than the ground state even. Consequently, population is flipped between E2 and E1. Higher amount of particles will get collected at E2. The chromium ions present in the E2 will have the spontaneous emission. A small percentage of the chromium ions will return from E2 to E1. A photon has a wavelength of, here the released photon will have the wavelength of 6943 angstrom. This photon passes through the ruby rod and it's traveling parallel to the crystal's axis. It is reflected back and forth by the rod's silvered ends until it excites the other excited ions which are present in the metastable state. Therefore, the stimulated emission and amplification of the stimulated emitting photons will be the outcomes of the reflection. The laser transition is this stimulated emission. By stimulating the chromium ions, the two stimulated photons will expel more photons, increasing the number of to 4 and so forth. Photons multiply because of this process done repeatedly. A very strong, narrow, red light beam with a wavelength of 6943 angstrom appears through the partially silvered end of the ruby crystal when the photon beam is strong enough. Since the laser beam is achieved between the both levels of E2 is the upper level and E1 is the lower level in the energy level diagram, the ruby laser thus falls under the category of three-level laser systems. So what we have seen over here, the chromium ions in the ground state, they will accept the external energy given by the xenon flash tube. They will get excited to the excited state. As the excited state is having a smaller time period, they will have non-radiative transitions to the metastable state. Metastable state will be a state with higher time period. So by the virtue of absorption, higher amount of chromium ions will get collected at the E2 and there will be the population inversion. When some of the chromium ions from E2 will have the spontaneous emission, they will release energy. That energy will act as a stimuli for the further ions present in the metastable state, and thus there will be stimulated emission from E2 state to E1 state by releasing energy of 6943 angstrom. So this is the working of ruby laser. Ruby laser is having certain kinds of drawbacks. As the terminus of laser action is in the ground state, it is difficult to maintain the population inversion. This facts result in ruby laser's low efficiency. Ruby laser requires high power pumping source, and at the same time the laser output is not continuous but occurs in the form of pulses of microsecond duration. Also, the defects due to crystalline imperfections are also present in the ruby laser. Ruby laser has very high output power of the order of 104 to 106 watts. It has wavelength of 6943 angstrom. Ruby lasers are used in the holography, industrial cutting, and welding. So this is all about the construction and working of ruby laser. If you are having any doubt, put that in comment box. Thank you for watching.